Yes, hello everyone. My name is Thomas Ahlström, and I am the manager of East Sweden Game. I'm so happy to see so many people here today. I will talk a bit more later after the fika, but just a short introduction to East Sweden Game for those who hasn't heard about us. East Sweden Game is a community for game developers in Östergötland. We have offices in Linköping and Norrköping, and we exist because we want to establish and grow the games industry here in the region, of course. And our vision is to create the best ecosystem in the world for game developers. And we need to do that together. So that's one of the reasons why we're here today. Felicia, do you want to say something more before we get started, or? Yeah. Okay, you will see more about with me later.
Okay, so I want to start with why visualization is such a powerful tool. And I want everyone in here to go to themselves. Think about your own senses. So let's say that the taste represents 1, talking about the bandwidth from the taste to your brain, that represents 1. Next up, we have smell and hearing, it's 10 times bigger. Touch, it's 100 times bigger. Well, everyone knows if you burn yourself, you react very fast, right? But of course, what's absolutely biggest when it comes to the bandwidth from the vision to the brain? It's 1,000. So what does this mean? Well, if you want to communicate something that's important, you have 100 times better bandwidth from the eyes if you use a picture or visualization than if you just want to make someone to understand by hearing. And to do that, to do a visualization, you have to also work with the data. Everything from collection, both real and synthetic, to the filtering, the analytics, the mining, to actually do this kind of visualization. And that's where we come from. So I have the privilege to be responsible for one of Europe's most attractive innovation environments for visualization and image analysis, where we are in a flagship environment, both here in Norrköping and in Linköping, with an excellent research environment hosted at Linköping University. And of course, we have around plus 100 companies that says they are experts in this area. And together with them, we drive innovation in different ways. It could be through events like this with a focus area. It could be as easy as a breakfast meeting, making people meet. And together with them, we drive projects. So up to today, we have plus 90 projects within Visual Sweden, which we are, of course, very proud of. And today we're going to talk about the topic about how we can use gaming technology outside of the game industry and how we can make value of that. So first up, welcome up to stage, Lena Klasén.
So, I'm probably used up 2 of my 10 minutes. So how come we are here? I'm Lena Klasén. I'm adjunct professor at Linköping University at Computer Vision Laboratory, but I also work at the Swedish Police. I've been the head of forensic lab. I worked with sensors and image analysis all my life. I use it for 3D modeling, biometric identification, use a lot of sensor for different purposes. So how come we work together, police and gaming industry? That's what I'm going to explain today. Felicia talked a lot about Visual Sweden. I'm in the board of Visual Sweden, and we do a lot of really cool stuff in Visual Sweden. Some years ago, like 2018, 2019, I think me and Martin Holmberg from RISE said that, why don't we put together a lot of researchers with a lot of competences, technologies, methods, and data and see what happens. And actually a lot of things happened because we went to a city of Västervik. Everybody brought their high tech and their competence and the methods and so on. to see what we could do. It was actually a long way to go from the project participant asked us when 19 different partners asked, where's the work packages, where is the expected outcome, etc., etc. And we say, we have no idea. We're just going to go there and see what happened. And it did. It was a very sunny day. Everybody was there. It was like a Christmas Eve with sensors. And this is what you can actually achieve. So you can model the world with not only just 3D, but you can use infrared camera, you can use spectral cameras. And here is the tower. We set up a crime scene, of course. NSA prepared a sort of a stage murder with a doll. Here depicted this with all kinds of different sensors, scattered light, hyperspectral, 3D LiDAR. This is the tower scene in infrared. Why? Why do you want the infrared? Because, for example, it's a very hot roof. You can suspect that people are growing weed inside. And you can also melt away the ground to see if there is something hidden underneath the surface. It wasn't. It was kind of boring. No surprises. But this is actually what you can achieve. You can make a 3D model of the world so you can see what's happened. And everybody, like in court, for example, can see the same thing. And this is the crime scene again. So the next project we did was SmartWin. And we wanted to apply all this knowledge into forest. Why is the police interested in forestry and forest? How do you take care of the forest? But I think that crimes happen in forest too. So I'm very interested. And this is actually Drottninggatan in Stockholm. It was a terrorist attack some years ago, 2019, where a lot of people got killed. So this is a big crime scene. At the time, I was head of forensic lab, and we did a 3D model of the scene. You can imagine if you show this in court, and if you want to Google, you Google NFC video Drottninggatan, you can see the entire scene there. And you can see it as a perpetrator sword. And you can imagine if you show this to court, it gives you a completely different overview of what happened instead of reading a lot of materials. And here we are now. This is actually a 45 minutes speech given at Sweden Innovation Day last week. So you can find it on YouTube. But these are 3D models of forest. This is Maxar's forest model, and this is a company called Deep Forestry. So we really have 3D models of environment, which we now can elaborate further with. So we are here now. We have a lot of really good 3D models. We can even find fungus from spectral camera. We can find a lot of dead trees and hot areas and classify all the kind of materials. So this really is a smart model. And so I have 2 more minutes. And this is a DALI interpretation of a lovely Swedish fika table watercolor style. So this is what came up. So, you know, you go to all this meeting, you go to breakfast meeting, lunch meeting, and network, etc., etc. But all of a sudden, this really pays off because I think it was like 6 months ago or something. I was here at Ebbepark with my colleague Niklas Fock. He worked at AI Sweden and WASP. And he said, you have to come to the fredagsfika this morning. Okay, fika is fika. So, and there we met Thomas. And that fika actually is the reason to us being here today, because we were talking about how can we use a heavy data set that we have for 3D model with all kinds of information. How can you use, we have this problem with hardware, but you said you have gaming platforms. What a good match. And this is the result of it. So I think I stopped there. This is my goal. This is what I want to do. I want to bring this to the Swedish police so you can actually make a 3D model of a crime scene. You can see the person, you can measure the person, the size of the person. This is biometric information. This is the height and the shape and the motion pattern, etc., etc. And this is the event, so you can replay this in court. And actually, we have done. So I stop there. So thank you.
So I've been in the game industry all my life, and I do a few keynotes around the globe. So I just thought I'd give you a super quick overview of the gaming sector. I should probably keep an eye on my watch there. So basically, it started, let's say, with real video games 33 years ago with Super Mario and Sonic. And I was in that camp, and then I was with Electronic Arts. But at that time, it was only video games. And every 5 to 6 years, there was a new console coming in to the market. Because at that time, it took a gaming studio roughly 2 years to develop a new game. And all the game development up to here was mostly in Asia, Japan and US. And when you launched game, you had first Japan, wait 6 months, then US, wait 6 months, then Europe. And what really changed the world, because I've been swapping around between Sega, Electronic Arts, Nokia, Microsoft, Minecraft, and Warner Bros., was that this guy, he changed everything from a global footprint. He's like I would say, the entertainment's Machiavelli. Because when iPhone launched, it immediately became a global footprint. You could do content all over the world. And there was a few early adapters, mainly Minecraft, that also went direct global. Same with the Finnish Angry Bird. So the whole world changed with iPhone, because I was one of the global guys with Nokia 4 years before iPhone. And I said, it's not going to work, because the operators or carriers, as they say in US, was controlling the content. And then if you go forward years after years, you have a platform called Steam, which has 33 million daily users. And there is one company here in Linköping, where I'm actually a board member now, Pugstorm, where we have a game early release. We sold 1.7 million units already. We're probably tracking 8-10 million units. And then you can calculate that with 400 Swedish kronor. So then you have Steam, and it's constantly, so you had first console game, 2D, 3D, PC games, mobile games, VR games, AR games, sort of, esport. And that's the evolution constantly going on with the new technology. Then you have virtual global office like Discord. And I think that's just a grasp on the industry. So we can go to the next slide. And if there's any question later on, I will let you know. So roughly 200 billion business. And there are this. They asked me to come to Tokyo to talk to 50 investors why Sweden is one of the best countries in the world. And then I thought, well, why is Sweden one? How can we be so early? Well, which I haven't put there. We were first in the world with grupparbete, so we're quite good working in team. We're also good in predicting milestones, which is very important in development. But we had a massive talent pool with ABB, Nokia, and Ericsson. They were constantly engineering, because this company was like, hire a few thousands, fire a few thousands, hire 2,000 because of the stock market. And we collaborate. We also think global from day one. If you see that also with big companies like IKEA, Hennes & Mauritz, but Mojang and Paradox, this well-known company, thought, let's think global from day one, which was obviously easier now when Steve Jobs rocked the boat. And we also both humble and bold, because we always quite often say no thanks to being acquired. Most people in gaming industry doesn't care so much about the money. It's just fun to work. And I was advising Minecraft when it was really heated, 2010-11, because everybody wanted to buy them. And they managed to say, no, 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 no. And then 2.5 billion, okay, we said. But I mean, that's one thing. And also today's fathers and mothers, they've been playing video games. So we have it in our DNA. We obviously, this, you know, I mean, in one of the cities today. But also löntagarfonder, pensionsfonder, Avanza. We have an exit system. It's easy to invest in gaming companies, and you understand gaming entertainment as an industry sector, which clearly help. And also lately, we have a good geographical coverage where we have knowledge, talent. because gaming industry is incredibly hot today, over 200 billion, much bigger than music and movies. And you have governments like Canada, Malaysia, Germany, Finland, which invest tons of money into this sector. Sweden invests 0 kronor. And I can ask why, explain why at the moment. But that also works because we have municipalities. I can never say that in English. How do you say commune in English?
Municipalities.
Wow, thank you. Jag kunde inte säga fåtölj när jag var liten, men det var en annan grej. So, and I'm traveling around a lot because I sort of live in 2 places, London and Stockholm. And I was also interested in talent. And then Malmö asked me to do a study, invest in Skåne actually, to where is the best gaming clusters in the world. And I was like, wow, I like that, because with Electronic Arts, of course, I visit Vancouver, FIFA, and so on. So then you think, then I did a study which my daughter wrote, because I'm not good in writing a 60 pages report. But we actually cover most of the world except China and Korea, obviously due to transparency. And what do you need in a gaming clusters? And I would say Linköping is today probably what you call second in place after Helsinki and Nordic. Linköping, Norrköping, Östergötland, I would say is the most active in Sweden today, which is amazing because you had Gothia Science Park in Skövde, which I also was advising 2010-11. You have Malmö, you have, of course, Skellefteå with the I forgot the English word here. I was so prepared to speak Swedish, I couldn't swap batterifabriken i Skellefteå. So you have a lot of clusters in Sweden, and I actually know the Minister of Culture in Denmark, Copenhagen, looking now, how can we do a cluster? So what's the best clusters in the world? What do they need? And I'm really sure of this. An excellent environment that smart people want to live in. Yes, we have a tick in the box in this region. State-of-art infrastructure, intertelecom. Yes, critical mass of talent and service to support high-tech industries. Yes, because for example, in Malmö, they have a lot of things, but they don't have private investors. One challenge is that startup companies, we have one there, in gaming, they're looking for investors. Are they going to go for family, friends, and fools, or are they going to go for companies? How are they going to seek money? So you need an exit system for investors. You need obviously a university or folkhögskolor, and you need connectivity to the world. I'm advising Sundsvall a little bit now, and I think, whoa, how do you fly to Sundsvall? 1 a day, but you have the train, which is great. So connectivity to the rest of the world. Linköping, yes, you can fly to Amsterdam, KLM. Is that enough? Not sure. But I would say it's a tick in the box. Being at event, establishing C-level contacts. You can see here everything. But also one thing was informal gathering, which was interesting to see Lena's opening remarks here also about fika. Informal gathering is incredibly important when it comes to this cluster to inspire and get advice. So I would say this is what I come to the conclusion with my report, which actually a lot of countries have seen now. And if you then look into your region, I'm really impressed. I mean, with everything like Sten Gunnar, St. Kors, how do you look into do this simplicity with Thomas' passion and now extending that collaboration? Because gaming technology is of course also business to business, gamification. I don't like that word, but you have security, you have VR, you have the police work, how you visualize things. And also gaming industry has really tight connection to KKN-näringen. So when I talk about gaming, I see a broader picture from that point of view. I think that was more or less my 9.5 minutes. Okay. So I'm around if you have any question about gaming. Thank you.
And now we will hear about one of the demonstrator, and Martin will explain your need. What was the need that you had that you took into this project, correct?
Yeah.
Yes, I will hand over the mic to you.
Yeah. Thank you. So I have my colleague with me, Jimmy, who joined me for the presentation. So we actually prepared this in Swedish, but we will try to make a live translation. So yeah, so we represent the Swedish Police Authority, and as part of that is National Forensic Center. So we got in contact with these guys within East Sweden Game, and we started to formulate a task that we wanted to get solved. So I will give you a bit of the background, how this all started. So the background, and then we will tell you a bit about reconstruction of a real crime scene that happened in Linköping a few years ago. And then we will formulate also the task that we were giving to Lutra to help us to solve. So within NFC, we have visualized a couple of crime scenes during the years. And Lena mentioned early in 2017, we had the terror attack in Stockholm on Drottninggatan. That was like the starting point to make a 3D model of the crime scene. In 2019, we made another visualization of a shooting incident outside of Jönköping, where we have some guards outside a nightclub, a car passing by, a drive-by shooting. And we tried to investigate how close was this that the guard was hit by this bullet. So we made a visualization of that as well. And then the reconstruction we'll show you later on here is an attack that happened at Linköping Resecentrum in 2021, and how we tried to reconstruct that scene in order to explain what happened in a better way. So how do we do to capture these scenes? We use this laser scanner. It's a terrestrial laser scanner, and how it works is this one is big like a shoebox, and we put it on a tripod, so it's like my height, and the laser shoots laser beams, and it shoots actually 42 million points out 42 million points when we spin it. So it goes like shooting lasers like this in 360, and then it turns like 1 degree, and then it measures. So it's actually a measuring equipment. So it ends up in a point cloud. So we have a room like this. It's million of points then, a point cloud. And we have an accuracy of like millimeters within these models. So we have a very high accuracy of the scene we want to capture. And when we have captured the scene in 3D, we can bring more understanding of the scene. And we have also the possibility to position stuff within the scene. To go back to the scene and see where was the gun, or where can we find the bullet and so on. Or we can put like cars or victims back into the scene using photos and so on. And further on, we are also able to make like different kind of 3D analysis within the scene. For example, from which direction was a gun fired? So you try to find the trajectory and so on. So this is the basis for our work. So Jim is going to tell you about how we reconstructed this attack in Resecentrum back in 2021.
Sure. This is the scanner and the scene, which was, as Martin said, Resecentrum. This is just brief summary of what we did to capture it. We had like the 3D scanner, and for the reconstruction of the event, we used the CCTVs in Västercentrum, which is actually more than 5 cameras, but we only use these 5 which were in the underpass of the railway station. And our job was to position all the persons that were passing through this underpass in a 4-minute event of time. And this was the result was then supposed to be a 3D animation. So I don't know if you're familiar with the Centrum, but these are the cameras. If you go through there, you will probably see them if you look up in the roof. There's these are the 5 in the underpass. 1, 2, 3, 4, and the 5th one over here. So to reconstruct the persons moving, we didn't have like a method with the analysis, so we did manual repositioning of these persons. And we could say that all of them were on the floor. There are some staircases as well, but we used the floor to set the position of these persons. The floor is actually like a perfect grid, so that's the kind of accuracy we get on the repositioning of these persons. So then from the 3D model, we get like X, Y, and skipping the Z direction. And all these positions had like a timestamp from the CCTVs as well. And if we had multiple cameras showing the same thing, we could verify that the position was really accurate. So yeah, this is just, we set the position like on the, what do you call it? Center of gravity, yeah, for the person. So right between the feet. So this is showing how we did it. This is one of the persons who actually sees the attack, and he walks forward and then starts calling 911 or 112. So I set the position for these persons right between the feet, and then timestamps gives me more positions, and we could use this to animate the persons. And the result from this, we'll start this. So yeah, this is a part of the result, which is actually, this is the 3D model, but we see it like a 2D version of it. So the perpetrator is the one in yellow, and the victim is the one who comes soon, a red person. And this is the movie that was shown in court. So the giveaway from this is that we don't have to see the really gore stuff. Anyone can see this, and you still get the picture of what is happening. And you even you don't have to see all the cameras, which is kind of confusing when you have 5 cameras to look at the same time. So this will show you the summary of everything. So this is actually like a 4-minute movie, but I've cut it down, so I think it's like 1 minute or so. And pardon? Yeah, if you saw that, but yeah. He had like one of those, what do you call it, segways or something, and he was hitting him with that and also with the helmet. And there's a guy, the green guy is also involved, having his backpack, hitting with that. And all the persons around here are actually calling 112 right now, except from the guy in blue is still standing and shouting. Yeah, good question. Since this is only like the position of the feet that I had, but I wanted to show them the court that this is actually when the persons are falling down. And I don't have like a really good position of the head, so I was only using the feet as the base of this cone, and like the tip would be the head. So then back to the project here we were introduced to. Actually, we were asked to like have some kind of requirements for gamification of this, and from what we can see, this will give like a better understanding of an event, and we could use the spatial information, which is a really good thing, and the movements of the persons here, and also we could introduce like other stuff like cars and other things that are moving. So we want actually to show the scene of events, be able to play it forward and backward and pause it, and when we have it in 3D, we could view it from different aspect angles, which gives an even better understanding. We could also like show what kind of information we want in this. Do we want to show the trajectories, or do we want to show overlays of the CCTVs? Turn that on and off. So this is the scenario we were sketching on, which was supposed to be like a gang-related shooting. Parts of the event should be shown in the cameras, and some were not to be shown. So we have to like figure out what is happening when we don't see things in the cameras. And we also said that we could use like bullet holes or trajectories from that to show kind of where were the shooters or shooter in this event. So this would be the thing that we left to Nils and his guys. And this is like the end of our slides. So thank you.
My name is Nils, and I work at Luttra Interactive as a 3D artist. And what I'm going to present to you is now the thing that we created, the interactive visualization of the fuss in Garnisonen. First off, while sitting down with NFC and AI Sweden, we concluded some different points of interest that, firstly, those that Martin and Jimmy mentioned, about making this visualization and making it in real time. So real-time graphics is something that we do a lot when we make games. We need the possibility to refresh a scene in real time and be able to like maneuver the scene and look at it from different angles. So this was the first task of making, these models that they already have into something that we could get into an engine without our computers like burning up because of all the detail. Second thing was the positioning. Thing with that, I guess, is the possibility of looking at video footage and being able of, in a like easier way that maybe takes somewhat shorter time, take people and put them into this 3D scene. And lastly, then to bring a lot of information together in the visualization. So we have people running, we have cameras, and we have the timeline, and we can scroll everything and look at all the information at once. So here's the model that Jimmy showed us earlier. As I said, it is a point cloud mesh, so it is really dense. And as you can see, this is not a real crime scene. We chose to use this test footage, I guess, of Garnisonen to just not have any problems with the usage of footage and everything in this project. But I guess it's the same kind of detail that we usually have like on Resecentrum and other places. So it is a point cloud, and this means that it is like these tiny just points everywhere, like atoms that kind of construct everything in an area. And this is something that we like, or I don't ever work with when making games. So just seeing this from the beginning, like, okay, how are we going to get this into the game engine? If we have a look at the background, or like how we usually do, we also have points in space, but then we tie them together, and on the areas between all the points, we then can draw some textures. So, which is basically just 2D information. So we draw the details in these 2D images. Yeah. So how do we go from here to here? Is the question. Yeah, no, we did not make it so light as this one. This one may be like 200 polygons or something, 100 to 200. So maybe like, I don't know, 150 points, while this is like, that's a lot of points. Yeah. So there are a lot of nice programs to make this work, but unfortunately I have to like have a lot of money to throw at the creators of those programs. But there are some open source and free programs like this one, Cloud Compare, that actually NFC also uses to fix with their point clouds. And by using it, we could make a surface reconstruction. It did not go really smooth. You can see like on the border over there that there are some problems with the directions of these points and normals, and everything gets weird. So we had to make a lot of these kind of bakes and kind of like puzzle them together to make a good unit. Yeah, but so the first one we made, this was like the largest mesh that I could construct in my computer without it like just crashing. So it's of 40 million polygons. That it's still like too much to have inside the game engine. Maybe Unreal nowadays, but Unity will not like it. So then I like reduced the model even more. And when we get down to like this, like 69K polygons, then we still have some problems with like the details vanishing. You see that it's all like smooth, and yeah, we miss a lot of things over there. So to be able to like reconstructing it, we use something that's called baking that we use a lot when making games. So we take a high polygon model, a model with a lot of polygons, and we combine it with a low poly model, which is now the one to the right side over here. And we kind of project the data of lighting from the high poly into the texture instead of the low poly. So by using this method, you can see like to the far left there, this is the optimized mesh, but without any like textures. In the middle, we have a normal map, which is information from the high poly. And then to the right, we have it all, but with a color map as well. To get a hold of that, we also had to make like the same procedure to have it back with the point cloud and project the colors of the point cloud onto the 3D model. Some things were not possible, like vegetations and these nets in the fences and so on. We could not reconstruct that in an optimized and good way. So then we just like manually modeled it and used point cloud as a guide for where to put everything. And then also we use a skybox. So you see it looks a little weird. We have that building over here, and then just by we have it again, but in the sky. So this maybe we would not have done like in a game, but now when it's interesting with like, we have the model, which is interesting, but then also it's very interesting to see everything outside and like, okay, so there's a building over there and there's parking and everything, but without us really having to model it. So the cameras kind of created all these different pictures at all the positions. And there were like 7 different positions that we used, or that NFC used to make it. And then you could like puzzle them together into a cube map and then wrap it around the whole scene to get this sort of skybox thing. Okay, so now we have a model in Unity and we can like walk through it and it's not lagging and nothing is burning up. But we still have a problem, and we need to have a crime scene. So we went down to the place where we scanned everything. So here we have NFC, AI Sweden, East Sweden Game, and Lutra all coming together to make a gang shooting. So we recorded everything. We set up some temporary like CCTV cameras. You see Lena down there holding a CCTV camera or something like it. And then we had footage to use in our 3D scene. So first, to like align this footage with the 3D view, we used program named FSpy to align everything. You get to set up all these vanishing points, and it kind of calculates where the camera comes from. If you've been to Gunnison, you know that none of these bricks are straight and everything is wobbly, so we did not get like the best data from that, but kind of close anyway. So then we could manually like set the camera in the right position, rotate it, and get it all to work. And when it's in the correct space, we then can like project the camera footage onto the 3D scene. And by also using motion tracking for the feet, we get these points that we then can like project down, and then we find the position of the characters in the scene where they are. And it is animated with everything, so we get the whole thing in an animation. And we did just like Jimmy with like, we have these feet coordinates and we take like the position in the middle, and that will be where the character is. But then with some differences and some fixes. Yeah. So in the thing that you will see and can try like after this on the Fika, you see them as capsules. But we did also try with some other AI tools like deep motion to make some more like defined animations of the characters. As we actually only had like the location of the feet as a good place to go from, we could not like get the Y coordinates right of how it works. So we did not bring that into the final thing, but it was really cool. It kind of worked. So AI, I think, will be a great thing combined with this later. So, and then the last point, like bringing everything together. So when you try it here at the Fika, then you see that you have all these different options that you can look for. We have the cameras and we have the timeline. The 3D meshes are like in sync with everything that happens in the camera footage, and we have some bullet trajectories. So by viewing the video, you can see how many shots that are fired and how many shots that are not in the target. So then maybe you can find like the conclusion of who actually shot the person. Yes, the person being our intern Pablo, I think he's here today. Yeah, yeah, hard times. Yeah, so check it out during the Fika. Another thing that we also did, which was not like related to NFC, but to Norrköping's airport, that I will not go through the whole process of how we made now, because I probably have gone over time or something. But it's the possibility of driving a drone through a large scene of Norrköping that is created by Norrköpings kommun and was handed to us, and we're like, whoa, this is a lot of things. So you can fly the drone. You have these different trajectories from your drone and then other planes and drones that goes through the scene. And yeah, you can make something out of that. So yeah, that's all I think I had.
Hi, my name is Robin Silverhav, and I'm the CEO of Northbit. I've been working on this project together with Jakob Paulsson of the company Rint. The project is called GeoVis, and it's a visualization project for urban environments in Unreal Engine 5. During the project, we collaborated with Norrköping kommun, who provided us with the data, and Linköpings Universitet, where Erik Heldén has provided us with his expertise regarding visualization of data and processing. We also collaborated with Visualization Center in Norrköping, where we used their equipment and rendered 3D videos for their dome theater. And the project was partially financed by Visual Sweden. The goal of the project was to create a visualization platform that could render this type of geographical data by leveraging advanced rendering capabilities of modern game engines to produce an interactive and realistic 3D urban environment in real time. So this is what it looks like. So everything you see here is running in real time and nothing is pre-rendered. It is running on my personal computer. All videos here are shown from the central part of Norrköping, which is where this test data we got was provided. So let's talk about what makes GeoVis the ecosystem. It can be simplified into 3 steps. The first is data collection. The data that we got provided to us by Norrköping kommun was mainly collected using aerial photography and laser data from planes. But this could also be collected using, for example, satellite photos and manual collection. The second part is data processing. It's done by classifying objects and areas and converting data to formats used by different pipelines, extracting relevant data from larger data sets and combining different data sets to get the required information which could be visualized. The third step, which is the step that this project has mainly focused on, is the visualization of data. It's when it's presented to the user with some interactivity. And we also have worked on a pipeline for parsing data from Lantmäteriet and visualizing. The main reasons why we chose Unreal Engine 5 for this project was Nanite, Lumen, and the landscape system. So what is Nanite? It's a virtualized geometry system introduced in Unreal Engine 5, designed to handle massive amount of high-quality geometry in real time. It works by streaming only the visible portions of detailed geometry into memory, eliminating the need for traditional level of detail techniques. Nanite is also optimized for modern hardware, so it's more efficient for resources and performance. And in using this, we are able to use large, high-resolution models in our large-scale landscapes without having to generate a lot of level of details. Lumen is a real-time global illumination system, which is also introduced in Unreal Engine 5. The main point of this is to simulate indirect lighting in a more accurate and efficient way than traditional means. And it does so by using global illumination, which simulates the reflection and scattering of light to make more immersive scenes. Lumen is also seamlessly integrated with Nanite, so you can have really high resolution meshes, which still works. And the landscaping system is a terrain creation tool in Unreal Engine 5, which allows for large-scale environments. It uses data streaming to load data as the player moves and deallocate data which is not used anymore. Here you can see the whole landscape of our test data, and you can see one of the landscape tiles selected there near the middle. A big part of this project has been to build custom tools for Unreal Engine using editor utility widgets. So the first tool we use for height maps, where we parse metadata from TIFF file to found the bounds of the world, and then convert it to a supported format used in Unreal. This is done using the Geospatial Data Abstraction Library, which is open source library. There is still some manual work. The tools aren't perfect yet. And the result is a textured terrain which has support for SVRF coordinates, which is the most common coordinate reference system used in Swedish data. We also have our model importer, which is used to bulk import models, in our case, houses. These models are of the FBX type. This is just to show a bit of the workflow and how we can actually create these environments. Yeah, and as you can see, then all the buildings end up on the correct SVRF location on the terrain. Third tool is our shapefile importer. Shapefile is a really common way to represent geospatial data. And we have support for both point data and polygon data. So here we can choose a directory with a lot of shapefiles and then select different actors to spawn in per shapefile. For point data, we use instanced static meshes to reduce the number of draw calls. And yeah, here we can also see that the water is converted from polygon data in the shapefile to static meshes, which uses water material, but also deforms the landscape to avoid clipping. And to allow for different user experiences, we have built a system for creating interactive visualizations in GeoVis, which we call scenarios. The concept is that a scenario is responsible for loading data and creating actors that is needed on setup and then cleanup afterwards. Here we have a few examples of scenarios. In this demo scenario, we can see the advantages of having the buildings as separate objects from the landscape. The user can interact with them separately. Here, the user can select buildings and get basic information about them. This information could be either baked into the spatial data, or it could be fetched from an external API. GeoVis is also able to fetch live data and move actors around the environment. In this scenario, the tram scene is moved to, based on the real world position fetched from external API. There's one request per second that fetches all positional data, and then the trams are moved along splines to make the movement smooth. Also, we use a fancy camera effect for this one for some reason. This demo shows how you can visualize data flows. So this could be, for example, traffic or pedestrian data in the city. And here is an interactive scenario where the user can place two different types of buildings around the environment. The user can also move the camera and zoom in and out. And for each building placed, we use particle effects as a visual feedback and sound effects just to enhance the user experience a bit. And it feels a bit like SimCity, but in real life. Yeah, and a big part of this project was to create something that was interactive and not just something that's pretty to look at. So we wanted to support different type of user inputs to enhance the user experience. So here we use a large touchscreen table around the project with. And this could, for example, be used as an exhibition piece. We also have support for producing pre-rendered 3D videos. So we created a set of short videos that was played at the Dome Theater in Visualization Center in Norrköping. This theater uses 6 projectors that project their images on a 165-degree screen in 8K, which creates a really immersive experience. And rendering, I think we rendered 1 minute and 50 seconds of 8K 3D video, and it ended up being about 400 gigabytes of data. Yeah, so to get in touch with us, here you can find our website with more images and videos. So that's it for me. Thank you.